Alright, so here in this particular video we have a beam of monochromatic light that is reflected and refracted at point A, and it says here the index of refraction in medium 1, which is where I'm circling back and forth, has a value of 1.33, and then it says material 2 has an index of refraction of 1.77. So here's N2 in the middle, and that is 1.77, and then here it's going to exit through air, and N3 here being 1, the index of refraction of air is accepted to be 1. Alright, so here since the incident beam makes an angle of 50 degrees with the first interface. So as shown here in the schematic, here is the 50 degrees that touches the interface or the boundary between these two first mediums. And then it asks us to do A, B, and C. So let's crack it up. Alright, so to do part A, it's just what is the angle of reflection at point A. So point A being this junction here at the normal line here. So this one's pretty easy. The angle that touches the interface or the boundary here is given as 50 degrees. So therefore, to find theta 1, you can just simply take 90 minus 50 because this is a right angle where I'm tracing back and forth with my cursor. The angle between the horizontal line here that I'm going back and forth and then the normal line that's perpendicular to the surface is 90 degrees because perpendicular is 90 degrees. So therefore, the answer here is just 40. Okay, so theta 1 here is 40, so therefore the angle reflection must be the same, which also is 40. So the answer part A is 40 degrees. All right, now that we have that, part B asks us to find what is the angle of refraction in material 2. So material 2 here is right in the center. So this one's not too bad. In order to find the angle of refraction based on the information given in this particular problem, you would just apply Snell's law. So I'm just going to focus my attention here between medium 1 and medium 2, or material 1 and material 2. Alright, so I'm just going to go ahead and apply Snell's law. Snell's law set the index of refraction of the first medium times the angle of incident must equal to the second index of refraction times the angle of refraction. Okay, so let's crack it up. Here, to solve for theta 2, because that's what it asked for. It asked for the angle. I'm just going to go ahead and move variables around so that I can get theta 2 by itself first before I plug in values. So the first thing I'm going to do mathematically here is get rid of n2 in order to get theta 2 by itself. So I'm just going to divide both sides by n2, which moves it to the left side in the denominator. But as you can see here, this is sine of theta 2. To get theta 2 by itself, you just do inverse sine or divide both sides by sines, which will cause it to become inverse sine of this whole left side. So now that I have theta 2 by itself and the statement, I can just go ahead and plug and chug. N1 being 1.33, theta 1 here being 40 degrees. Here I highlighted the 40 degrees is because in Snell's law, the angle of incident and the angle of refraction should be referencing the normal axis. Okay, so why the diagram here gives you the 50 degrees that touches the interface, it is important that you don't use 50 because 50 degrees here touches the interface, not the normal line that's dashed here in this diagram. So that's a common trap. Alright, so here I'm using 40 degrees because theta 1 touches here the vertical axis, so the normal line. Alright, other than that, it's just plug and chug. N2 is just 1.77. Which is given, and then you plug all this in your calculator, the parentheses quantities simplify down to 0.483. Inverse sine of that will give you an angle of about 28.88 degrees. All right, so that's the answer for part B. And then part C asks us what is the angle of refraction in air. So once it goes from medium 1 into medium 2, it's going to exit into air, which is medium 3. So therefore, we can just crack it out real quick. We can just apply Snell's law again, except now your option is to go from medium 2 to medium 3, or material 2 to material 3 here. So I'm just going to go ahead and change the subscripts. So I'm really using Snell's law again, except I'm just focusing on material 2 to air. Okay. So same algebra step. To get theta 3 by itself, I would go ahead and divide both sides by n3, and then I'm not done yet. Theta 3 is not by itself yet. I would now divide both sides by sine, which will once again cause it to be inverse sine, and then plug and chug. N2 is given as 1.77. Here, theta 2, we already calculated. The refracted ray in medium 2 is 28.88, and this angle touches the normal dash line, once again, between the interfaces here. Okay. N3, which is air, once again, the index of refraction of air is accepted to be 1, and then just plug and chug. Simplify that, you'll get 0.8549 in the parentheses, And then if you do inverse sine of that quantity on your calculator, hopefully in degree mode, that'll give you 58.75 degrees. And that is the answer to part C. What I do like to point out here is if you're given a choice, excuse me, if a method is not dictated for you, you do have a choice of how you attack this problem. So if I can bring your attention here in my first statement here, n1 sine theta 1 equals n2 sine theta 2. However, what I did set up also between material 2 and material 3 is n2 sine theta 2 is equal to n3 sine theta 3. Here I have a statement for n2 sine theta 2. Here I have a statement for n2 sine theta 2. So as you can see, I can actually set these two statements equal to each other. So ultimately, I can bypass that second medium if one is not asked of me. So I can actually just go from medium 1 to medium 3. Why? Because n2 sine theta 2 equals to n1 sine theta 1, but n2 sine theta 2 also equals to n3 sine theta 3. So I can set those two statements equal to each other. So you can just bypass the medium in the middle if you like, okay? So therefore, I kind of simplify this diagram down for you. So if you like, you can actually just reduce this diagram on the left if you choose to. Just go from medium 1 to medium 3. And if you set up Snell's law, you can just go from n1 sine theta 1 equals n3 sine theta 3. And if you pump out your work, the answer will be the same. Okay, so keep that in mind. You do have options to skip mediums if you like. All right, stay nerdy. Don't be whack.